compare mentally. What should y contain? Okay, first, if it is a perfect square, we know that the powers must eventually be positive. So I show you the different methods already. Depending on your method, some of you can actually shortcut and tell me that y is equals to 2 times 3 times 5. And that gives us 30. If you're able to do this straight away, let me start working just like that. And this is perfectly acceptable also. Yeah. Only working. But if you're not working, you show the intermediate steps, sure, go ahead. Okay, once you have practiced enough already, this is enough. Okay, next, yes. I don't understand. Okay, come, let me go through. A, y is a perfect square. Right, so if I have a, y, it will look like this. A times y, 2 power 5 times 3 power 11 times 5 times a blank. And here we have y. When I multiply everything out, the powers must all be even. Right now, let's take a look at number 2, the factor for 2. Is it an even power? No. What must we multiply it by in order to get an even power? By a 2. Then we'll bring the power up to 6. Likewise for 3. Currently there are 11. I need an even number. So I multiply by 3 again. Similarly for 5. Get it now? So actually just need to compare the powers. 5, the next one must be 6. So I multiply by a 2. 3 power 11, next one must be power 12. Multiply by another 3. Similarly 5, you only got one of it. I need another 5. So that will be times 5 again. So 2 times 3 times 5, 6 times 5, 30. Answer. Okay, so let's try example 2b. In the same manner, Bm is a perfect cube. What is the smallest power for smallest value for m? Let's take a look at the first prime factor, which is 2. How many more 2's do we require? Already there are 4. How many more do we require in order to be able to split them into 3 equal parts? How many more? 2 more. So 2 power 2 times. How many more 3's do we require? Just 1. How many more 5's do we require? And write down the value. 4 times.
200.
How much?
300.
300. 200. 200. Okay, sure or not? You're giving me different answers. Okay, 300. Answer. 4 times 25 is 100 times 3, 300. Okay, same approach. But this time we make sure that the powers are all multiples of 3. No longer just even. 3a. Different type of question now. Okay, watch carefully. Look at compare the two questions. Here we have C over P. Now we are doing a division. Earlier on, it was all multiplication. Okay, so again, I'll show you the intermediate steps first. C over P is 2 power 3 times 3 power 6 times 5 divided by a blank. This will be my P over here. And I want it to be a perfect square. Okay, the final answer must be a perfect square. So what do I expect to see for all these powers? Okay, there are some blanks we need to fill in. When I divide 2 power 3 by another prime factor 2, what happens to the power? Become bigger or become smaller? When I divide by, for example, a 2 over here, what happens to the power for 2? 2 power 2, isn't it? So originally in my numerator we have 3 of them. 2 times 2 times 2. But because I want a perfect square, I cannot have 2 times 2 times 2. I need the final answer over here, this power, to be an even number. So because the only option I have is to include something in the denominator. They say P is in the denominator. Now I am free to put in some numbers in my denominator. If I choose to put a 2, what happens to the final power for 2? There are 3 on top, 1 below. So you cancel how many? Cancel away 1, right? Left how many? Left with 2. Okay, so I know my final answer should have 2 power 2. So compare this approach with the previous type of question where we had something like this. C times P is a perfect square. Okay, versus look at the different type of question. So this will give us 2 power 3 times 3 power 6 times 5 times a blank. And we call this P. So these are two different types of question. One is a multiply. So we know that, oh, this must be 2 power 1. Because I want to bring the power up to become 4. Whereas here, we want to bring the power down to become 2. Because we are doing a division. But same approach. Right? Okay, now let's try 3 power 6. Is there a need to do anything to it? No need. Because it is already an even power. So I know that this will eventually be a power 6. What about the 5? Is this currently an even power? No, it is not. It is power 1. So what do you want to change it to become? Take note, you cannot go up. You cannot say, I want the 5 to have power 2, so it's a perfect square. Cannot. Because now we are dividing. So what do you think is the final power for 5? 0. If this is power 0, that means the 5 disappears already, right? 5 power 0 is 1. You can use your calculator again to convince yourself 5 power 0 is 1. So if I put in a 5 over here, my final answer, my C over P will become 2 power 2, because there are 3 of them on top. Then I divide by 1 of it, I'm left with 2 2's. Then I still have my 3 power 6, no change. And finally, the last 5 and 5, they cancel. So now my remaining value is a perfect square. And now I can look at my working and see that, hey, my P value is actually 10. Okay? Can? Okay, then let us now try 3B. D over F is a perfect cube. I will go through the intermediate step again. Then you will be doing 3C by yourself. Okay, let me go through the steps again. D over F is actually 2 power 3, 3 power 5, 5 power 2 divided by a blank. And I want the final answer to be a perfect cube. Does 2 have a multiple of 3 as the power already? Yeah, I have, so no need to change, 2 power 3. Does my 3 currently have a multiple of 3? No, right, it is currently 5. So what is the multiple of 3 that I should change it to? Is it 3 or 6? Should I change it to 3 or 6? Very good, it is 3. Why is it not 6? Cannot increase. Why cannot increase? Because it's division. When you divide, then the power gets smaller. Okay, so this is what I want it to become. How about the 5 squared? Should it still be there? Cannot, right? You decrease, then it should disappear already, ma. So you can choose to write 5 power 0, but I'm lazy, I'm not going to write it. Because 5 power 0 is 1. Multiply by 1, don't bother writing. Okay, so how do I go from this to 2 power 3 times 3 power 3? What should be the denominator? Do I need to do anything to the 2? No need. Do I need to do anything to the 3? Yeah, okay. How many 3's are in the denominator? 2 of them. So you must visualize there are 5 3's in the numerator. I want it to be left with just 3 of them. That means I must remove 2 of them. And they are found in my denominator. What about the prime factor of 5? How many in the denominator? 2 of them. So my final answer for F is 3 squared times 5 squared, which is 225. Can you try 3C by yourself? Part C, I want it to be a perfect square. What goes through your mind? Everybody look at the screen. Even if you already know how to do it, watch and check whether your understanding is the same as mine. If it is different, either you ask me in class or you ask me later on. So if it is a divide by h, I know that all the powers for A will eventually decrease, they will drop down. Since I want it to be a perfect square, I want the final answer to have even powers. Right now I look at 2, it has power 5. So I need to drop it down to become power what? I want power 5 to become power 4. And I do so by letting h be equal to 2. Then for 3, since there are 11 of them, I need to reduce to become 10. So there's only 1 3. I don't want the 5 anymore. So I need to divide by 5. Answer 30. Do you have the same answer? Okay, the method that you use should give the same answer also. So this is the shortcut. Next, example 3D. Similarly, for the shortcut, instead of powers even or multiples of 2, what do you want the powers to become now? Power 3, multiples of 3. Okay, so currently 2 power 5. What do you want it to become? 2 power 5 becomes 2 power 3. How do you go from 2 power 5 to become 2 power 3? We need to divide by how many 2's? I got 5 of it, I want to become 3, so I must divide by how many 2's? 2 of them. I've got 3 power 11. I want it to become 3 power? 9, yeah. So I need to divide by how many 3's? 2 of them. I've got 5 power 1. I need to reduce it to become 5 power 0. So I don't want the 5 anymore. What must I do? Times 5. So work this out. 4 times 9 times 5. 180. Okay, who needs more time to copy? Then do so quickly. If you are done, move on to exercise 11 and 12. Square numbers are perfect squares. Okay, now we'll go through part A. I have the feeling that when I teach, you can follow. But then when I teach you another concept, you forgot what you learned previously. Then cannot be the case. But I understand because we haven't done many practices yet. So this is our practice plus your homework, then you'll be able to do them properly. Okay, so for part A. Now, I want b times k to give me a perfect square, meaning powers are even. Currently, my b has 2 power 3. That's not even. So I need to include a 2 to make the power become 4, which is even. Then I have 3 power 4. No need to do anything already because the power is even. What about 5? Include the 5. So this is 10. Okay? This one will give you 1 mark. If your answer looks like this, A, 10, just like that, this 1 mark only. But if your presentation is like this, oh, A is 10, I will give you 0 marks. Because I don't know what it refers to. You must at least write K equals to 10. As long as I still can accept. Okay? Don't just leave numbers hanging by themselves. Now for part B, B over H is a square number. H is now equal to 2 times 5. That gives us 10 again. Part C. Q equals to 3 power 2 times 5 power 2. And for part D, M. Okay, part A. Since I want it to be a perfect cube, it will be 2 times 5, which is 10. Okay, so this is M. Part B. Highest common factor of A and B. HCF is 2 squared times 5 power 4. And this gives us how much? 2500. Part C. Oh no. LCM of A and C. I'm greedy, I grab everything. LCM 2 squared times 5 power 4 times 7 power 6. Index notation. Part D. A over n is a perfect square. N equals to 7. Part E. AP is a multiple of B. LCM of A and B is, so this is the method 2 that I'm using. That's how you prefer method 2. LCM is 2 squared times 3 power 3 times 5 power 5 times 7 power 5. So our P value is equal to this LCM 2 squared times 3 cubed 5 squared, 5 power 5 times 7 power 5 divided by A, which is 2 squared times 5 power 4 times 7 power 5. Final answer is 3 cubed times 5, which is, ready? 27 times 5, 135. So can do, alright?